Alright, hello, good afternoon. So, I hope the sound is okay. Right. Alright, so I'm gonna start the live stream for today. This is a tutorial live stream for Houdini, and this is 161st episodes, and the topic for today is to create so-called Zen wall. I mean, coming from a comic AKIRA, Japanese comic AKIRA, and a type of a wall crack on the wall, which looks like this circular wall, circular crater-like walls, which is similar to these images. I think this kind of image has been invented by Otomo, one of the manga creators. And what I'm gonna do is to try to make this crack on the wall, circular crack on the wall, procedurally using Houdini. Right. So this is the test. This is the goal that I'm going to create today, and you could pretty much create a variety of this crack using several parameters, like the complexity and yeah, all sorts of parameters you can control in order to control the randomness, as well as this random seed, random variations. You can also control the radius. And you could also make it animated. This kind of create more cracks on the surface, on the edges, so on. I mean, just a fun project for me. I'm just gonna share this to you, how I create it. Not really practical maybe, but could be interesting for some of you guys. Okay, so that's what I'm gonna do. Okay, so I'm gonna put this to a different display, and let's start. So the basic idea is to create these crack lines using a shortest path node. Okay, so basically these craters are being created by the center forces on the wall. So what I'm gonna create is a kind of a network like crack lines from the center of this wall, like a spider net, and use that as a base for the crack line. Okay, and using these lines to make wall cracked. So most of the time when you create cracks on like physics simulations, you might use Voronoi, but instead I'm going to use a different method today. So that's why I'm saying it's not really practical, because you do need to do a lot of settings. Okay, so let's start by creating a wall. Just creating a grid on XY plane, and let's make the rows and columns 2 by 2, so it's a simple plane. Okay, and first thing that I'm gonna do is to make this plane remeshed and use the edges as a path candidate for the shortest path node in order to create a spider net like crack lines. So I'm going to use a remesh, control the density. I'm gonna go with 0.1 as a target size, so you have enough density to make a complex network. Okay, make the iterations 10 so that the triangle faces becomes regular uniformed as much as possible. Okay, next, what I'm going to use this find shortest path node to create a network. Now to do that, you need a starting points and the end points, right? I would like to set the starting point to a center of this wall, and for the goal points, I'm going to create random points on the border. Okay, it's my plan. So first of all, in order to get the border points, I'm first going to create a group node to set the, what's this? Group node to create the border points, border group for a points using include by edges, unshared edges, so that all the points on the border will be selected as a set it on the group. I'm gonna just pick one of those points out of this border group to be used for the goal for the shortest path. Okay, so before doing that, let's also set the center point, which is going to be the starting point. So I'm going to create one, or I'm just going to create one single point, which is going to be used as a center point, I mean the center of the network. And what I want to do is to make this point snapped into a closest point on the mesh, which is somewhere around here. Okay, so I'm going to use a simple wrangle node to snap it onto the mesh, to the closest point on the mesh. Okay, hi everybody, thanks for joining. Not sure how I'll be able to stick to whole things. Yeah, I'll record the video so that you can come back to watch this later, anytime. And I'm gonna plan to also upload the files that I'm going to create today, so you can also check that as well after the live stream. Okay, so what I'm gonna do is to make this point stick or snapped to somewhere around here. So what I'm gonna do is to use a near point function, look for the nearest point from the second input using the current point positions, get that point positions and update the current point position with the nearest point so that it will be snapped to the closest points on the mesh. Okay, so that and after I have snapped it, I'm going to use, I want to set the group for this mesh on this current point position as a starting point to use it as a starting point for the shortest path. So let's get the point from the second input, or I can just say position from the second input. Calculate the distance between the current point position of the mesh and the position from the second input, and if the distance is close enough to 0, which means you're looking at this point, set that point as a start group. to be used for a shortest path. Okay, now for the endpoint, I don't want to use all the boundary information, so I would like to filter it to a random number of points. Probably somewhere around like 5 to 10 points on the border, randomly picked. So what I'm gonna do is to use let me see, what did I write? So what I'm going to do is let's see, so I'm going to use a point wrangle, and looking at the border points, then randomly pick a point on a border, then use that point as a ending points. Now in this case I might want to set a number, how many points that I want to get from the boundary. So let's get some parameters as an integer. Let's say I want to have 5 points from the border. Now what I'm gonna do next is to first of all get the total number of the total index values for the border using expand point group, which will give you all the point numbers within this border group. And now you could what I could do now is to, let's say, I could shuffle this border group. This border group and this border number always start from the smaller value to the larger value, I think. So what I want to do next is to shuffle this list, and to do that, let's say I'm gonna create a argument array for randomness. Loop through all the border numbers. And create a random number for each loop using iteration I as a seed plus some seed value from the parameter. Okay, which will create a value in between 0 to 1 for each loop. And then I'm going to append that values to this list. Now I can create a order informations using arg sort by inputting the randomness random array and then I could use this order to shuffle this border array by reorder the borders using order informations. Okay, then the border array has been shuffled. I can then pick the value from this border from using the index number that I currently in. So let's say if pt number is less than number, then I could pick the border from the borders, and using ptnum. Wait a minute. Yeah, does this gonna work? I'm not sure. Let's try. And for this border point, I'm going to set the group called end, or yeah, end. And let's see if I really got 5 points on the border with this logic. So I'm gonna test it by using a color node. Set the end, color it red, and if I have 5 points colored in red, successful. So I see 1, 2, 3, 4, and do I have anything more? Let's just check on the spreadsheet. So if I have, so I only have 4 ends, which is because I guess I needed to make this like this. Is that it? I'm not sure. If I make it 1, I do get 1, 2, I get 2, 3, 4, 5. Now when it is 5, I didn't really get 5 points, so not sure why. Anyway, well, doesn't really matter about detail, but let me just change some algorithm a little bit. So once I have reordered, shuffled it, let's say I'm going to use a find functions to look for the border using ptnum. Okay, which will give you an index value for the borders list. Then use this function. Instead of ptnum, I'm going to use index, and then using ptnum to set the group. Okay, that will do it. Okay, so now you should be able to choose a specific number of points for the border, this method, and I'll try to use these border points as a target and center points as a starting point for the shortest path. So let's try this out. Let's connect this to find shortest path, and for the starting point I'm going to set start. For the end point, set end. And since I have multiple number of end values, I'm going to choose from any start to each end. Okay. Now if I change some randomness, you see a base cracky line start to happen, but it's a little bit too straight. Currently it's a bit too straight. If you look at the reference image, it's a bit curved. It's a bit dodged, like these. Not too straight, have some ducking, some rotations throughout. the lines, so like to make a bit more randomistic for the path. So in order to do that, you could go to path cost, and by introducing like cost attribute for distance and the rotation, you could somehow make this path a little bit more organic. So let's try doing that. Okay, so to do that, I am going, let's call this end. Now after I have set the end, I'm going to set the cost attribute to each of the points on the mesh and use that to control, kind of modify the bumpiness of the surface so that the path, the shortest path, will be changed based on those costs, which is based on the graph theory, I think. So you could control two costs. One is for the distance, one is for the angular costs. So I'm gonna try to set both of them to see the differences. So first thing first, let's try with the distance. I'm gonna call this C1, cost 1. I'm gonna try to use noise function with the smoothness of the noise, as well as some seed value. Let's make it really big for this one, and multiplied by the actual length or magnitude. So currently I have 3 parameters. One is seed, similar to random seed. I have smoothness and also a magnitude. So let's set the magnitude to 1 for now and smoothness to something like this, and try using it as a cost for a point cost attribute right here. So to use this, I have to put this into an attribute. So let's put it into C1 for the point. Let's see how it changes the path. Okay, so it kind of did change a little bit. And let's try changing the parameters to see what kind of changes we get by changing the smoothness and the magnitude. So more magnitude you have, at some point it just stops changing its path. For the smoothness, more values you have for the smoothness, it gets more randomish. Yeah. And you could also control more randomness by checking this omit distance from cost, which will ignore the distance attribute from the cost, which will make this a little bit more randomish, I think. Yeah. So what I'm gonna choose is to omit the distance, which seems to create a bit more randomish values. And one more thing you could do to make it a bit more random is to subtract this noise value, which is in between 0 to 1, by 0.5, which will give you a negative 0.5 to positive 0.5 as a value, which will create a more drastic randomness like this, which is kind of interesting, but this is a bit too drastic. So let's make this a bit too drastic, I guess. And changing the magnitude doesn't really change anything at this point. Well, it's a bit too drastic, I guess. This happens because the change from negative value to positive value is being treated really drastic in the cost calculation, I guess. So what I could do, maybe I shouldn't really using subtractions here. Doesn't really look good, I think. Or you could uncheck. Well, it doesn't really change anything. So I'll just make this positive for now. Okay, one more thing that I want to try is using this angular cost attributes. So I'm going to check the consider turning costs and check angular cost attributes. I also would like to use that one to see the changes to the path. So I'm going to create another noise-based values. I'm just going to copy these using different parameters. Using different number of sword seed, magnitude, apply it to a point attribute. Okay, so let's try making the C1 to 0, the smoothness to 0, so it doesn't really affect the cost currently, and just try to use the C2 that I've just added to see the differences. Now if I increase this smoothness, doesn't really change much, does it? Also the magnitude doesn't really change. So what if I do a subtractions right here? Would that change? Oops, not this one. Nah, it's a bit too dirty here, so maybe the subtractions might not be good at all. So now the rotation doesn't seem to do much, but if you try to combine with these, I think it will start to make a bit more sense. Let's see. Not too drastic. What if I add... Oh. Now this is a bit drastic, I guess. Yeah, changing the smoothness doesn't really make a good result, so let's forget about using subtractions for this. Okay. Now I have got the base, but I think just having these as a base spider net split curve is not enough. I think I would like to have several of these to combine with, have a bit more organic and complex network for the cracking. So what I would like to do is to repeatedly doing this approach, this part, for several times and merge the network that I got for each iterations and use it as a final network for the cracking. Meaning I'm going to use a for each loop and put the now the starting point doesn't change, so what I just need to do is to change the end point and the cost value with the different randomness. So I'm just gonna put these set inside a loop. Then for each iterations I need to change the randomness. So let's set this meta node to a second input of the wrangle, get the iteration value, and use that as a additional seed value somewhere around here. And also here. So I'm gonna copy this one to a cost. And let's just copy or multiply this to the seed value. Might be a bit better to be bigger. Okay. Now you have a bit more emerged randomish network being created. So it's combination of this loop and the number of points you choose right here. Then you could also change these randomness or these smoothing values. Or the magnitude. I guess the magnitude is okay with 1. What makes it more drastic is the smoothness, I guess. So that will be the base for the spider net-like network. Then what I'm going to do next is to create a horizontal crack based on the circular cracking lines to these baseline. Okay, so let's do that. But before doing that, let me see. I'm going to create a null node and collect all the values that I want to control later, so that I don't have to come back to each node every time I want to control something. So first parameters that I want to control is probably the mesh resolutions, I guess. So target size, I'll call this mesh res. Okay, now the next parameter is the number of points of the boundary to pick. So that will be number of target on boundary. From 0 to 10 is, I guess it's fine. And also how much you're going to repeat the path. Path creation. And this could be from 1 to maybe 10 or more if you like. I'll go with 10. And you have several parameters in order to control the cost. Now let me check back again the parameters. So we have a seed, So smoothness will definitely change some cost, some path. So let's call this path cost 1 from 0 to 10. And we have another path cost 2. Zero to 10. Okay. And let's go back to the find shortest path if I need to do anything else. Yeah, I guess that's pretty much it. And apply, accept. Let's see what we can do with these parameters. So I can change the path. Okay, I forgot to set the seed. I also have the random seed, which can be used to control the randomness or random variations. Okay. Let's copy this, and probably I need to use it right here as well. Copy this, paste it here. All right. Oops. Copy it, paste it, plus some additional value here. Okay. So now you can change the variation using the same settings. Okay. So, and you can also change the numbers, boundaries. Okay. So should be good for initial test. And now I would like to make more circular cracking lines from here. Now before doing that, or maybe I could do, what I could do is, so let's check back what we have here. So looking at these geometries, you see that I can maybe see a long line from the center to the edge, something like these, and then if you see it as a long line, then you have this section, you have this segment as one piece, and then this piece being split into several pieces using these circular line from the center. So looking at these pieces, maybe this line is the one and this line is the one to create a segment, and you have a bunch of lines to split this shape. So the idea is to first of all create a segment using this line to split the mesh, split the current mesh using the line that I've just created. And for each segment I'm going to create a circularly cut using a different lines, and for those lines I'm also going to use the shortest path. So let's first create the segment using this line. So to do that, first of all, there is a chance that many points are being on the same positions. If you check the point numbers, you see several points are being placed on the same positions, so I don't really need that, so I'm going to fuse it. Okay, so that you can reduce the number of points. Now let's try to split the mesh into segment using these lines. The mesh that I'm talking about is this one. I don't really need a color, I think. So let's do this by making the point unique in order to split. Using unique points. And to use the unique points, I need to set the point group to make which points needs to be unique or split it. So I'm going to create that group informations for the points on the mesh, which belongs to this network, which is pretty easy to define. You just need to check the distance to the curve, and if the distance is close to 0, you can set that point to a split point. So you can just calculate the distance, x, y, z distance, and if the distance is close enough to 0, then set point group split. Okay. So let's check with the color which point has been marked as a split group. Okay, so it looks correct. So now for this group, I'm going to use a unique points to actually split the points. Now as a result, the mesh has been split it into segment, I think. Oh, something's not right with the selection. What's this? I think I'm having kind of weird selection mode. Huh. I'm not sure what's happening here. Let me see. What's this? Let me just try saving this and reopen the file. See if we can fix it. Nope. Anyway, let's try using a connectivity. So for each connected pieces, I'm going to set the same class attributes for primitive. Let's try to color it based on the class informations. See if it's correctly split it into segments. Okay, so pretty close, I guess. Why am I getting this weird selection mode? I think I did something wrong, but I don't really know what. Anyway. Okay, so looks okay, but there is a bit of problem in this settings. If you check somewhere around here, you see these primitives are not belonging to pieces on the left or right, just one single primitive for each triangles, and that is because of the original curve something looking like this. So that was the reason. Okay, so to make it cleaner, I guess what I could do is to make those primitive which has only single neighbors or one or two neighbors, belongs to one or two class, or only has one or two total class values. By using connectivity, then you could maybe merge into the neighbor primitives to make it a bit more to get rid of those small parts. So that's what I would like to do next. Looking at the connectivity, you have bunch of classes, and there's a chance that there's only one class value, which is pretty much isolated from the other pieces. So for those parts, I could probably merge it into neighbor primitives. So that's what I would like to do here. To do that, I'm going to use a primitive rankle. And merge small to big. First thing first, what I would like to do is to check for the same class and count the number of primitive sharing the same class attribute value. So I'm going to use a find attribute val count, and looking at the primitive attributes, and the attribute name is the class, and check with your own class for each primitive. And if the count is equal to 1 or maybe less than 2 or 3, that means you only have small number of connections, maybe let's say 3. Then let's put all the class which has only less than 3 classes as make the class to -1 to share the same class for all the small parts. And let's also call this, let's also put all these primitive into a small parts group. Okay, let's check with the color node again to visualize based on the class, and now all the small parts have been merged into one, like these. Okay, which looks better. I mean, they are still small parts right here. So in order to fix that, let's see. This is not really connected to anything. So can I just try making... I don't really know why am I getting this weird selection mode right here. Let me just check with the other Houdini. No, it doesn't happen in the other one. I think I did something wrong here. Okay, let me just close this file for now, reopen it, see if I can fix the selection. Hopefully I'll do. Okay, now it's fixed. I don't know what was happening, but previously I couldn't really select. Okay, so for now it looks good. I do still see small parts here and there, but it's fine for now, since I need to do the similar process again later. Now what I'm thinking right now is that maybe the number of like path goes to number of paths that I have right now is a bit too small, so let's increase the numbers. Yeah, something like this. Yeah, looks good. That looks good. Okay. Now, after this, let me check. Let me go back here and okay. I think after doing this, I'm wondering if I should fix this small parts right now. Maybe I should. Maybe I should. Currently, this is not really connected to anything, and yeah, it's not connected to anything. So in order to fix this, there's one thing I could do. That is, let me go back here and let me check the color at this point. Okay. Okay, so the one that I did here is to just merge all, just change the small parts to be class equal to -1. But instead of doing that, maybe I can merge these primitive into the neighboring primitive, like putting this into this one or putting this triangle into this one and so on. So instead of doing this one, let's try merging it to a neighboring meshes. So to do that, let me check the primitive number if it's changing. Okay, it's not. So what I could do is, let's get the primitive. Okay, maybe I can just copy this one and connect this mark split into a second input which hasn't been splitted yet. Okay, which means it's all being connected. And what I'm going to do here is to get the neighbor informations for the primitive poly neighbors from the second input, because every mesh has been connected on from the second input using the current primitive number. The current primitive number is already being splitted because of this part, but this one hasn't been splitted yet. Okay, and this is the array. Now, and what I could do here is, if the count is less than 3, I could, instead of setting the class to -1, I'm going to search all the primitive inside the poly, the neighbor polygons. Like this. And check if the polygon has a class. Polygon primitive from the second, from the first input class poly. Okay, and then I'll do the same things that I did here. Look for the count for the class, neighbor count class. Okay, let's just call this n class. Stands as a neighbor class. And if the neighbor has more than 3, which means maybe you want to merge the one that has less than 3 to this neighbor primitive, meaning you can then overwrite the current class to the neighbor class if the n count is more than 3. Then once you found out the neighbor class to merge with, you can just leave the loop. Okay, then try recolor it. Okay, that seems to work. One primitive has been left out, but seems to work. Now I can recursively do this for finite time, which will just make everything in the end will be merged into a bigger class. So let's do that. So make it as a feedback loop, fetch feedback, which will iteratively do the same process over and over again, and then in the end you will see all the points, all the primitive, all the small primitives being gone. Maybe 10 is enough. Now these soar-like shape, I could fix it later, so I'm just gonna leave it for now for these soar-like shape, but everything else looks fine now. I no longer have a small parts from this. Okay, now that's good. The next step is to create a circular cuts. One for the whole total circular cuts like these, and one for small cuts inside. So let's create the outside cuts first, which looks like a circle with a little bit of noise. So let's do that. So to do that, what I could do is using, first of all, let's try creating a circle. Make the divisions high enough. Make it open arc, and let's try changing the radius. So let's have this parameter, uniform scale, as one of the parameters that I want to control later, so that you can control the size of the crack on the wall. Okay. Okay. So in order to create a path, what I'm just going to do is to for each segment that I have here, I'm going to create the intersection with this curve. Then on the border, maybe for each segment, and use 2 points to create the shortest path for each segment, and use that as a cutting line. Okay, so what I mean is that for each primitive, for each named primitive, which in this case I have named it as a class to group each segment, for each class I have to change this to class. Okay, and for each primitive, I'm going to cut this with this circle if it's intersected. Now let's try with the one with the bigger segment for first try. Okay, something like this. Okay, so let's try cutting this with the circle. Now, just cutting it as is not really clean. I mean, it doesn't really look like a crack. So instead of doing that, I'm going to use the similar process where I have created the edge for a crack. So meaning I'm going to use the find shortest path to create the cutting path. Okay, so to do that, what I would need is a intersecting point on the border somewhere around here, and intersecting border somewhere around here, and setting one of the point as a starting point and another point as an ending point, and create the create a shortest path between these two to create a cutting edge. Okay, so that's my plan. In that case, you could also control the cost to make it a bit more randomish from start to end. So let's try doing that. Now I need to get the border in order to calculate the boundaries. So first of all, I'm going to remove the shared edges. Now this gives me a little bit of problem on the edge. That is because it's not fused. So let's use fuse function. Okay. Then create a poly path to make it as an outline. Then try to create the intersection with these two curves. Intersect analysis. Now hopefully this will give you 2 points, but sometimes if the tolerance is too big, it'll give you more than 2. So I'm going to make this really small, like 0.001. Okay, now hopefully I'm getting 2 points. And what I'm gonna do is to try to connect these 2 points using the shortest path node. Now in order to do that, these points must be placed on top of the point of the current mesh. So I need to make this snapped to the closest point on the mesh. So let's do that, which I have already done previously, so I'm just gonna copy this setup that I have here. So snap can be placed right here, and I could use the second input to the curve, and that will move the points on top of the points on the mesh. Now I need to update the mesh itself to set the starting point and the end point. Now this one already has 2 points, so let's set the end point as well. So so if ptnum actually you have 2 points coming from the second input, so you have 2 distances. Okay, and if it's close to the first distance, you can set it to start. If it's close to the second distance, a second point, then you could set it as end. Okay, now that I have set the group for start and the end, hopefully I'll be able to use the find shortest pass. Now before doing that, there is a chance that previous starting point and end point has been preserved, so let's group delete and delete unnecessary or duplicated groups. One should be start and one should be end, just in case if it's preserved, that will do something weird. So okay, now let's try creating single network going from start to end, which looks like these. And you could also again control the path using cost attributes, but I'll skip it for now. Let's try seeing it on the loop and see if I'm going to get the connection, circular connections, and yeah, looks like I did. Let's see. There are some gaps here, and what's with these lines? Let me check. Okay, so something weird happening right here. Let me check here. That must be due to... Okay, so this is a mesh. Okay. Why does the shortest pass goes from this point to this point? Doesn't really look correct, does it? The snapping, did it work? Okay, do we have 2 points? Yeah. We have deleted the end group and starting group, yeah. And let me check where is the starting point and where is the end point. So the start point looks correct. End point, yeah, it does also look correct. And why do we get this as a result? So from any start to any end. Okay, I believe that is due to some duplicate start point time. Yeah, I thought I deleted it here, but it doesn't seem so. Or maybe this calculation is wrong. So previously I don't have a starting point, starting group, but right here I have 2 for some reasons. That's weird. Why is it? Why there's a chance that this D1 is gonna become less than 0.001 for 2 points? That's weird. Let's just check the start again. So this point has been chosen as another candidate for the starting point. Interesting. Let me check the distance. Okay, and the distance between position 1, position 2, right? Let me check. That's weird. Why is it becomes 0? Why this becomes 0? when there is a point positions right here. Huh. I don't get it. I don't get it. Am I missing something? This comes from the second input, right? Let me just check this one then. So when the distance is 0, the position 1 is, yeah, that's correct. And let's say position 2 is at P. Huh. So it's the same value. And has been set at the start, but I have 2 starting points. Okay, that's weird because this is distance more than 0, but it still set it as start group. Why is that? Let's set this right here, just in case. And check this again. Okay, now it looks correct. Maybe maybe I forgot to refresh the loop. That might be the reason. Okay, just check this again. Okay, let's just check this part, why I have the openings or gap here. Which supposed to be, oops. We just enable the circle. Somewhere around here, I guess. I do get the curve here. The one next to it. This one? Nope. Where does it come from? Single pass, single pass. Just need to know the mesh numbers, or maybe I can just go here and choose the corresponding one from here. So let's check this again. Okay, the purple one. This one. So I'm just gonna pick this up. And use it as a debug shape. Just check the first one. Let's see what was wrong. And I got the intersections, I got the snap. Should be able to get the starting point, and end point is not being retrieved. Okay. Okay, so there's 3 points. That was the reason. So maybe after doing the snapping, I should fuse it, just in case if the points is on the same positions, it'll be trimmed or fused. Okay, now you should be able to create the curve. Okay, better. Alright, so you could make the whole things back again. Okay, now you could still introduce the noise cost to a shortest path for this, but I'll just get this part for later if I have time. Okay, now I have created the a outer curve, outer circular cuts. I also want to do the inner circular cuts, but for the inner cuts, doesn't really look circular anymore, but you have random positions. You have these cuts on the random positions on the inner parts. So what I'm going to do for the inner circular cuts, I'm going to repeat doing this step for several times, and for each step I'm going to make the scale of the circle smaller, and using that smaller curve to trim with each primitive. Okay, so that's my plan. Okay, so to do that, what I want to do is to change the scale for each circles. So first thing first, I'm going to make additional loop so that for the first loop I can make the scale of the circle to the same scales that I have right now. Then for the next step, for the next iterations, I can change the scale smaller than the current scale of the circle, and randomly chosen based on each segment. So I'm gonna use for each number. Probably this will be a feedback loop, I think. So fetch feedback, fetch feedback. Let's start with least number of loops. So 2 loops, and connect this right here, and connect this right here. Okay. Now I'm already getting some errors here. What is it? Okay, let me see. That is because what I'm getting as a result is just a curve. So I think, okay, let me just make this one for now. I think what I should output as the result for the loop is the mesh itself, the trimmed mesh itself, which is trimming this original mesh into segments using this circular curve as a cuts. So let's do that, shall we? Where should I do that? Maybe within this loop. So I have the curve to split, I have the mesh to split here. So things that I need to do is similar to what I already have right here, which is somewhere around here. So let's copy this part. So things that I want to split is this one. Yeah. And the reference curve that, in order to use with the split is this one. Set it to the second input. Then you can split it using a unique point. Then you could now separate it into two. Now what's happening with these? Let me check back here. So this is all being, is it selected? Yeah. And is this also selected? Huh. Somehow this has been trimmed. Now that is because I realize I also have to delete the previous group. It's called split. So let's reset the split group. Group delete, split. Okay, that should fix. Nope. Group delete. So it hasn't been deleted. Oh, wait a minute. I have to delete from the first input. That's what I did wrong. Okay, now it looks fine. So it's being splitted into two segments. Okay, I think I also need to put this inside somewhere here. Okay, now let's check. So things are being splitted. Let's make these colored again by using additional connectivity. In the end, with the primitive, let's color it. Primitive ram from random from attribute class. Okay. So I seem to have some like circular segments happening. So that's good. Now what I want to do is to repeat this process for inner curve as well. So what I want to do is to make this process several times, and for each iterations I want to change the scale of this circle so that you could have a inner cuts. Okay, so let's do that. To scale the circle, I'm going to use a point wrangle. And since I want to make it, I need to have informations of the current iterations of the first loop and the first loop of this one and the nested loop, this one. The nested loop only has 2 iterations, so I just want to check if it's the first one or not. For the parental loop, I need to know the iterations because so that I can use it as a random C value to change the scale of this circle, which belongs to each segment. So I'm going to change the random values for each segment. So I need to create a meta node. Okay, create connections to this point wrangle. And let's get 2 iteration value, one for the seed, one for the conditionals to check if it's the first iterations or not. So if iterations equal to 0, which means it's the first loop first iterations, you can just make the scale to 1, meaning no changes. Else, you could create a random value using randomness based on the iterations. You could also use 2 as well. Maybe, yeah. And then add additional seed value. We'll create a random value in between 0 to 1. Now I would probably want to prohibit using value close to 0, close to 1, because that means you're going to have a cut close to the edge or close to the center. So I'm going to clamp this value in between something like 0.1 to 0.9, just in case. Now maybe I could update the scale value based on this randomness, then update the circular scale with this attributes. Okay, and then what happened? Something is not correct. Is it? So I do see a cut, but I don't see a outer cuts anymore, so why is that? If I make this to just 1, looks fine. If it's 2, doesn't look correct. So let me fix it. So is it due to a feedback loop, maybe? Let me see. So for the I'm gonna just look at the one big segment, something like this, and then check the loop for each loop right here. So starting with the single path, which is supposed to be the place for the circle, which looks correct. And if I make second loop, the first cut disappears. It's not good. So let's check. Feedback each iterations is fine. Fetch feedback, I think it's fine. Is it yeah, it's already been splitted, so that's correct. Okay, so this is not good using fuse node right here. So that was the reason. Okay, so instead of using this, can I just take this off? Now there's a problem because I would still need it for a divide node here, so I guess I should do this outside, maybe somewhere around here. Okay, so this part, we have some issues like here. It's not being connected. Even though you share the same class, it's not being connected. So I think I should fix those parts first before I get it into this loop. So to do that, you could, so this shares the same class, right? So attribute promote. I'm going to promote the primitive class called class, primitive attribute called class to point. Don't delete the original. And then fuse it based on the class attribute. Then you could just match all the points which shares the same attributes. Remove the isolation. Okay, so that looks good. Then I can go without the fuse here, I think. Then as a result, I should be able to get a secondary intersections and secondary segments like that. Okay, looks good. Now going back to a old operations. Okay, now I see that I'm having some random cuts inside like that. Okay, it's not bad. And then I could also increase this iterations to make it more cuts in within the curve, within the segments. Okay, the more segments you have, I guess more randomness you might want to introduce, so having path cost might make more sense here. Insert it here, but let's get back to that later. Okay, well, so you could control these parts, these values. Let's have it as parameters. Okay, let's copy the iterations for, how do I call this? A circular cuts number. Always starts with from 1, so 1 to 10 is fine. Okay, and this one is based on the class, so it's automatic. Anything else? Pretty much it's automatic. Now the seed can be shared with the original seed. I'll just come back later. Okay, so accept. Now you could control number of cuts for the circular. You can control the radius. Change the parameters, change the randomness. Okay, now you start to see again these small isolated parts, so you want to do the similar process that I did here. Okay, now let's do that. I think I could just copy these parts or maybe make it as a subnetwork and repeat using the same one. Let's say which part can be networked. So this is a split part, and I think this part, right? So the first input is the mesh, the second input is the fused mesh. Okay, and then fusing it based on the class. Okay, so this part could be subnetworked. Let's call this remove or merge small parts. Okay, let's copy this and connect this one, and let's just fuse everything. Connect this to the second one, and that will fix the small parts. Alright. Now the base is pretty much good with it. I think what I want to do next is to fix these jitters, or these soul-like shape. Okay, these one. I want to make it a more straight curve. Okay, so let's do that. And later I'm also going to introduce some randomness after I have make it smoother, so that to be able to look like a more crack-like edge. Okay, so let's see how I do that. Let me check what I've done. Okay, so first thing I should do is need to make sure these are all connected. Okay, now let's remove the inner edges first, like that. Okay, then fuse it. Then apply smoothness. Now making it smooth will give you a bit roundish shape, so let's reduce this to a small value like 1 to 2 so that I see less jitters on the edge like these. Maybe 2 is good enough. Okay, now this still gives you a more roundish shape, so I kind of need to make this a bit more noised or randomized for the edges. So that's what I'm gonna do next. Okay, so to do that, I am going to create some offset for each point using noise function. Okay, so I'm just gonna create a offset vector based on the point positions with the smoothness. Then subtract by 0.5, 0.5, 0.5 will give you a value in between negative 0.5 and 0.5 for all x, y, and z. Now I do not need the z value, so let's reset to 0. I only using x and y because this is the plane information. Now let's also multiply this by some magnitude to control the amount of noisiness to be added to each point on the edge. Now update the point based on this noise offsetted vector value. Now obviously the smoothness is a bit too small. Let's make it bigger to make it more rough, and make this offset value a little smaller so that the edge will become a bit more rough, like a crack. Okay, not sure what the right value is, but let's go with these. Maybe this is too much. Okay, somewhere on here. Okay. Now everything looks good. Now I am going to split each primitive again. Currently it's all being connected, so I'm gonna use the unique points, which will split the shape. Okay. Now the next step is to make this three-dimensional like a crater shape, just like we can see on the image, like these one. I want to create more like a crater shape like these from this flat image. So that's the next plan. Now just moving points to a crater positions is easy, but doesn't really look realistic as a crack shape. So what I'm going to do is a bit more mathematical process. So looking from the side view, let's say I want to have a wall like this. Okay, and currently I have a plane like this. And somehow I want to place this plane fit to this hole, but not too smoothly. For each segment, probably you have several segments. I want to make it as flat as possible when it's being fit to a hole. Meaning for this shape, when it's being fit to the hole, I want to make it something like this. Make it flat but laid on top of the hole shape. For this one, like that. For this one, like that. This one, like that. So see the flatness like this. Now in reality, I guess you should use a rotation, but I'm not going to use a rotation because I'm just going to, if it's a rotation, it's gonna be a lot of calculations needed. So instead of using rotation, I'm going to modify the point positions to fit to this position by preserving the plane normal to flat, but rotating. It looks like it's rotating to be aligned to the hole. And in order to do that, you just need a simple vector calculations. So let's say you wanna make this plane fit like this. So informations you have is the center point position of this plane, center point position on the hole. You also can get the normal directions of the hole, normal directions of the plane, which I don't really need it. Now, in order to transform this flat plane to a wall plane, what I could do is to first of all move this plane to here, moving the center point to the center of this center of this hole, intersected points. Then what I could do is to create a dot product between the position vectors from the center to each point and the normal. Okay, which will give you a projected vectors length for each point, which looks like so the position vector will be projected to this direction and projected this direction. We'll get a distance value, and this distance value can be used to move this point to the horizontal vertical directions in order to make it align with the whole shape. Now, I'm not sure if that makes sense, but I'll show you in practice. Okay, so let's try that. So let me check the original Houdini file that I have and see if I'm doing right. Now, first thing first, I need to know the center point position for each pieces. So let's get the center point positions first, which is just a primitive center. So yeah, it's not that hard to get. And I also would need the shape of this hole. Could be derived from the sphere shape. So I'm just going to create the sphere, which shares the same radius as the one that I have set here, crack radius. So I'm going to copy this radius and paste it to the uniform scale here. Okay, it should be doubled, so radius should be equal to 1, 1, 1. Let's make the frequency too big. Okay. And if I look at the pieces right here, you're just using the tip of the sphere in order to create the hole, in order to create the crater. So I guess I should move this sphere a little bit toward the front directions. So maybe based on the uniform scale, I'm gonna copy this, move the center to a negative z, multiply by 0.5 or 0.4. Now it's not aligning with the shape right here, so I guess I also need to make this scale a little bit bigger so that it will align with this shape. Just gonna do this manually. 1.2 might be too big. 1.1, 1.15. There is equations to do this, but I'm just doing it manually for ease. So let's try changing the radius to see if it's gonna follow. Pretty much. Okay, so it looks good. So now that I have a base shape to create the hole, let's use this sphere to actually create a crater. Now I need a normal informations on this sphere as a reference, which then used to be used for dot product to calculate how much distance you should move for each plane. Okay, let's increase the resolutions as much as possible. Okay, now let's do this. So I'm going to for each point on this plane, check the intersections to the sphere, maybe to the positive z direction, and if there is intersections you would like to move the center of the parts to the intersected point positions, then do a dot product calculations between the point position from the center to and dot product between the positions and the normal from the sphere, and use that value to move the points of the parts. Now I don't think you would get it, so I think I just need to show it to you. So first of all, get the intersection information from the current point position to the z direction. Could be really high. You will get the intersected point positions and uv. Now if you have got the intersections, which means you want to move the parts, you want to move that parts. Okay, now I let me see. Oh. Okay, so if there's an intersections, first of all, let's get the normal value from the intersected point position. Okay, then at this point, I'm not going to move the points yet because each point will give you a different value for intersected positions. So I'm going to get the average for later purposes. So what I would need at this point as an attribute for each point to be stored is the distance from the current point position to the interposition. Or maybe I can just get the center point position of this primitive that each point belongs to. The center can be retrieved by using primitive functions, looking at the P attribute. Then I guess I could just intersect from this center instead of each point. Don't I? Yeah, I guess so. So let's move this right here. So instead of using at P, I'm going to use center, which means I don't really need to do this on point wrangle, but I can just do it as primitive wrangle, meaning I don't really need to have this function, I don't really need this function. I can just go with this. At P now is the primitive center, then the normal that I got from the second input is the normal on the center point positions, which is good. Prim, why am I getting error with this one? Function for vector primitive. Vector norm, enter, UV. Let me see. No matching function, vector prim, candidate our matrix 2. Okay, I have to make it prim UV. Okay, then I don't really need the distance, just need a normal. Right, so I'm gonna place the normal, and I'm also going to set the interpost to intersected positions, right? And let's just set the center point positions as well, which can be set it outside. I guess that's it, and let's also have the intersecting information as well. Other than that, I guess that's all I need. Now I guess I could just move each primitive based on these informations right inside its primitive wrangle. Maybe I should do that. So I'm gonna call this fit to crater. So if it is intersected, I could then get all the points from the primitive, loop through all the points, if you don't like using the loop, you could have additional point wrangle to have this functions being written in that, inside that. Which could be faster, which should be faster, because you're not gonna use loop. Okay, so you get the current point positions. Now what you want to do is to subtract this point position by the center, which is at P, right? Then calculate the dot product between the positions and the normal that you have here. Okay, and using that point positions to update the point position of this. So new positions is at P plus or minus at P plus D, no, at P plus set 0, 0 D. Okay, maybe. And let's test it out. That point attrib P PT to this new positions, and let's see what happens. Oop, where'd it go? Where did it go? Okay, it's gone. What about, okay, my bad. It should not be at P because this is a primitive center, so it should not use that. You should use this one. Okay, so I have the pause. Let's make temporal positions, which is position minus at P, positions, and what you want as a new position is the point position plus D. Okay, it's the other direction, I guess. So it's negative D. Okay, close. Now I also need to fix I also need to make it sure that it fits to this surface here. I have just solved the rotation, but I haven't solved the location and transition yet. So in order to solve that, I will need this interpositions, which is the goal vectors and from the center point positions, which is at P. So there you go. Okay, now it should fit to the sphere and try to make the surface as flat as possible to make it look like a clack. Now it's not the actual rotation, I'm just projecting as a flat face, so it's not, doesn't really, the the area is changing, so it's not really physically correct, but visually it's fine. Right, looks fine. Now you could then multiply these parts with some parameter like animation value to animate these push or cracking cracking starts to happen from flat to crater. Now if you go without any color, look like these, and if you go without the edges, we'll go like these. Now another things that I would need is the gap between these parts, because currently it's all tightly fit, so even at the end you don't really see the gaps much. Doesn't really look like a crack especially on the edge. It looks really artificial. So what I would like to have is kind of these cracking edges starting to be able to see. Okay, so for that part I am going to control the scale of each part based on this maybe animation value right here that I have. Okay, so let's do that. Shall I do it within the primitive wrangle, or yeah, well, I think I should, because I have this parameter and I want to use this one. So let's just do this inside here. So this is where I'm controlling the point positions. So this is actually the point which I should also control with the scale. Okay, so I think I could start by thinking about scaling the parts from each part center together with the distance from the center of the whole crater. So if the point position of the part is far from the center of the crater, make the scale smaller. If it's close to the center, then make the scale smaller, if that makes sense. Okay, well, let's try. So this is the new positions, right? And let's try with the hard-coded scaling value like 0.6. And in order to scale it, you first need to make this new position moving to a center, which is in this case interpositions. Then scale it with the SC, move it back to a center positions, and the parts will be scaled like that. Now as you can see, it's not really, doesn't really look good at all, and I realize I want to scale the one outside as well, so I shouldn't write it here, but I should write it outside even without this conditionals. Okay, so in that case, that it might make more sense to do it outside this primitive wrangle. Let's just do it with a different wrangle value, shall we? Okay, so this is just fitting to the crater. I'm gonna add additional point wrangle to scale parts. Okay, And I do want to share the same animation value, so I'm gonna copy this value here, this parameter here to here. Okay, now let's get the primitive information from the point. ptnum, get the center of the primitive, and let's try the hard-coded scale, just like I did with the primitive wrangle. So at p minus center positions 0.5, add it back with the center, then update the point position with this one. Okay, so every part's being affected with this. Okay, now I don't really want to make everything with the same scale, but I want to control this value based on this animation value. Okay, so if I just add this animation here, what would happen? Start with the, that doesn't really look correct, so I'm going to use the fit functions to create the scale value, which will make it a bit more natural in terms of the scale based on the animation. Let's start with 1. Fit 0, 1 animation. Now when it is equal to 1, the whole crack should have been applied, so you might want to have a smaller value like 0.8, and if it's not, if it's equal to 0, you want to make it 1, meaning no scaling happens. If it's 1, have smaller value. Okay, now better than last time, but I also want to control the scaling factor based on distance from the center to each point positions. So let's also take that in account. Now to do that, you would need to control this part, I guess. So target scale, and using another fit functions, in this case this is the length of current point position, which is the distance from the 0, position. Or you could also say distance from the current point position to sit 0, 0, 0. It's the same meaning. And let's see if it's let's say, let's start with simple example from 0 to 1. I will say if it's 0, 1, 2.5, something like that, and let's try replacing it right here. Doesn't really look good. Okay, I guess instead of using animation value right here, I'm going to use the animation value within this fit function. Okay, so so for this one, let me think. So this is kind of offset value. So let's say -1 to 3 4.0 and let me see, let me think. So we have a distance and we want to let's just change this to length at p so it's easier to see. And then for this is where I want to use a animation value, I think. So animation, okay, I guess I will name it as move and fit 01 anim in between -1.0 to no 3.5 or something. Then use this move function give a small range which is belongs to this one, so let's set it as range. This is the distance, how much it should be affected based on the slider. Then make the last one to 1. Then multiply target SC. Okay, so now it start to create. Now this is actually too small, so let's make it like 0.9. Now you start to see more like a cracking animation start to happen. More like it. Okay, so I guess you could parameterize these like range, the minimum scale, and the maximum radius. So for the range, okay, so minimum scale, I'm gonna set it to 0.9. The maximum radius is how much is gonna be, how much does the scaling will be affected. So it should be bigger than this radius. So I think I can copy the radius value that I have here and get that circular radius and add it to this one. Okay, so that even if it's 0, it still works. You can kind of like control the range, how much edges you could get as a crack extension. Okay, sounds look good. And for the range, you could control the amount of changes for the animation. If it's 0, it just changes really direct. You don't see any smoothing scale between this point and this point. More value you have more smoother scale differences. Like that. Okay. guess I should be able to control should be able to have the negative value for the max spread as well. Yeah. Okay. That looks good, I guess. Not bad. So we have several parameters. Animation, the range values to control the smoothness of the crack scale, the maximum radius for the crack extension, and the minimum scale of the crack. Shouldn't be too small. Something like 0.9 looks fine to me. Yeah. Alright, then let's have all these parameters copied into the controller so that we can access it later. So we have an animation value, which is this one. And we have the range. How do I name this? Crack, smooth. How do I name this? Crack. Scale distance. Doesn't sound correct, but. And maximum radius. Crack, max, radius. Okay, I will go with. Actually, for this radius, I should make it multiply by small number because the actual. Sorry. Forget about it. Okay. Let's make it from -5 to 5. And for the minimum scale, I guess the minimum could be something like 7.7 is enough. Alright, so okay, looks good. Now, I think I want to have some thickness to this plane as well. I'll just use labs thickening, the easiest node to create the thickness. Alright, easy as that. And then done. The crack wall, so-called Zun wall, is being created. You see this character, this is Zun, right here. It's a sound effect. Alright, good. Now let's try changing some parameters to see what we gonna get with the different parameters. So the number target on boundaries, so this defines the number of nets on the border. And this also defines the number of borders. So you have small number of networks. If you want to increase this, Got more small cracks start to see. For a circular cut, if you have just one, you're going to have a simple, like a cone-like shape. If you starting to increase the crack within, it will become more circular or spherical. And okay, I think I want to copy this random seed to all the node which uses the randomness. Like this one is not. This one's not using it. It's not scale circle. Okay, so here it is. I can just add additional value here just to make some variations. Okay, I guess that's it. All the rest of the places I think I'm already using the seed. Okay. Now, where was I? What else? I think there's one parameters that I forgot to. Okay, so this one, what was this one for? This is to make, okay, so this is to make the edge noise. So if you have no noise, that looks more smoother. Doesn't really look like a crack anymore, so you do need some value here. So let's have that as a parameter. Okay, so crack edge smoothness. Let's make the maximum to 10 and crack edge offset. All right. What else? If I change the random seed, you're going to see tons of variations. And if you change the path cost, somehow it changes the path. Kind of randomize the path. Yeah. I'm not sure how much effective it is. And the radius, of course. So that's about it, I guess. Yep. So that was a so that was the process for creating a procedural wall crack or wall crater, so-called zone wall. Hey, let me know if you have any questions. If not, I think I'll just finish this live stream here. Okay, any questions? If not, I'll just finish this. The process is pretty straightforward, I guess. I mean, some of the process is not really, maybe not very straightforward, because usually, I guess, for these shapes, you would use Voronoi. Just wanted to try different method because I'm kind of bored with the Voronoi fractures. That's the only reason. I guess you could still do the similar things with Voronoi. And practically, I think using Voronoi should be faster. I think. Alright, hope you liked it. Let me also place the thickness to this. So it's not a physical simulation, so it's not physically correct at all. It's just the visual stuff that I'm creating here, so not sure how much is useful for anyone, but hope you find it at least interesting. Okay, so that's it. I mean, you, as a additional stuff, what you could do, maybe you could add some cost attributes for the circular cuts here. It might not affect that much because the distance is pretty small, so even if you apply some cost attributes, you wouldn't get much difference with these, but you could try changing these. Yeah. And oh, one thing, you might also want to be able to control this scale as well, so that you can control, oops, how much you can control the curvature of this hole, right? So if you make it 0.2, you have more depths, and you start to see edges not being following because these parts are not being intersected. So it's kind of a reason why. So I think it would make sense to make it less than 0.5. 0.8. You have smaller. I'll go with 0.5. Okay. But you could always control that. I mean, when you can change this, you also need to change this value based on the scale. Okay, that's it. Okay, so as always, I'm going to upload the file that I've created during the live stream to a GitHub as well as Patreon page, so you can download the file for free. I'm going to post the link to the file and the archive after the live stream finished to the video description page of this live stream. Okay, so that you can come back later to download the file to test out yourself. Okay. Okay, that's it. Thank you for joining. Hope you liked it, and hopefully I'll be able to do something next week if I have some ideas. If not, maybe another time. Okay, this is it. Thank you very much and good night. See you.